Welcome to my channel. In this video, I am going to explain the topic 8085 architecture. So 8085 microprocessor. Okay. So let us before going to see this 8085 microprocessor architecture. So we are going to see the features of 8085 microprocessor. Right. So the basic features of 8085 microprocessor is it is a 8-bit processor operating at the three operating at 5 volt power supply, and operating clock frequency is 3 megahertz, and it consists of 8-bit data bus and 16-bit address bus. So it performs 8-bit arithmetic operations. So that is the basic features of this 8085 microprocessor architecture. Okay, so now let us see the architecture details of 8085 microprocessor. So here in the top section, just see the top section. In the top section, that is interrupt control in it. So 8085 microprocessor consists of the following interrupts, that is trap, RST 7.5, 6.5, 5.5, and INTA and INTR. So all these are interrupts. Okay, that is external interrupts which are available for 8085 microprocessor architecture. Okay, now come to this side, there is serial IO control. Here the serial IO control is what? Serial data communication. Okay, can be done from microprocessor to other devices or other devices to microprocessor. That can be done by using this SID and SOD pin. So here SID pin is what? Serial in data. Okay, serial in data, and SOD means what? Serial out data. So data can be entered to the microprocessor through this SID pin, that is serial in data. Data can be leave from microprocessor to other device through serially, that is what? By using SOD pin, that is serial out data. So this is the serial communication control to enter the data to microprocessor and leaves the data from the microprocessor to other devices. Okay, so this section is what? Serial IO control. Okay, now let's come to the another part, that is accumulator. Okay, so let us see one by one. Okay, that blocks. So here the accumulator is it is the 8-bit register. It is the 8-bit register. So it is always associated with what? ALU is what? Arithmetic and logical operations. So already I told. So this 8085 microprocessor it performs the 8-bit arithmetic operation. So for doing the arithmetic operation, one input is always available at accumulator. This is the specialty of accumulator. So accumulator is having some speciality, so that I am going to explain here. So here accumulator is what? 8-bit register. 8-bit register. So it is always associated with what? ALU. Just see the diagram. Okay, so one input to the ALU is what? That is accumulator, right? And another input from, that is temporary data register. Okay, so I am going to explain this concept with an example. Okay, so for example, you just take the instruction add B. Add B is one instruction. Okay, so the meaning of that instruction is what? The content of accumulator, add B. Okay, add B, the content of accumulator is added with B register and result will be stored in accumulator. That is the concept of add B instruction. The concept and all explained in the previous video, that is 8085 addition. Okay, you just refer that program. Programming I have explained in the previous videos. You just refer that. I have explained clearly, right? Now here the add B is what? The content of accumulator is added with B register and result will be stored in accumulator, right? So one data is available at what? Accumulator. Another data is what? B. So that B data we cannot send the data directly to the ALU. Okay, first that B data is moved to temporary data register. That temporary data register, the content of B register is moved to temporary data register. That data is given to what? ALU. Okay, that is the concept over here. Okay, not possible to communicate ALU with any other register except this accumulator. That is the concept over here, right? Okay. Okay, so here the accumulator means, okay, after ALU operation, the result is always retained at accumulator. That is the concept, right? And also one more specialty is there in for accumulator. So the data can be read from the memory or write to the memory through only accumulator. Okay, so this that is the main importance of accumulator, right? So the data can be read from the memory or data to be write to the memory. Okay, so that can be done by using only accumulator, because we are having only LDA instruction and STA instruction. LDA means what? Load the accumulator content. Okay, and STA indicates what? Store the accumulator content. Okay, so there is no other instructions like STB or LDB. So that type of instructions are not available in your 8085 microprocessor. That's why the only possibility of moving the content, the kind of moving that is storing content to memory and loading content from memory, that can be done by using accumulator. And one more possibility is there, that is reference pointer, that is HL pair. I'm going to explain later. Okay, that one. Okay, so this is the speciality of accumulator. Okay, so what is the accumulator functionality? So accumulator is 8-bit register. It is always associated with what? ALU. Okay, one of the operand is written at accumulator. Okay, and the result of the ALU operation is always stored at ALU, and the result of the ALU operation is always stored at what? Accumulator. That is one point. And another point is what? The data can be read from the memory or data to be write to the memory, that can be done by using this accumulator. Okay, this is the speciality of accumulator. Now let us come to the data temporary data register. Already I explained this temporary data register. So this temporary data register is what? That is second input to the ALU. Okay, so whatever the operation you are going to carried out in this ALU, so one data is available at what? Accumulator. Another data, okay, whatever the register you have mentioned, so that data is transferred to what? Temporary data register. That temporary data register will give the input to ALU. That is the concept. For example, add B, already I explained. So add B means one data is available at what? Accumulator, and another data is available at B register. That B register is the content of B register is temporarily moved to temporary data register, that will provide to the ALU to perform the operation. That is the concept over here, right? Next, come to the flag register here. So flag register is what? It is going to update the status of the ALU. Okay, so after ALU operation is performed, so what type of flags will be affected, whether it is carry flag, parity flag, sign flag, zero flag. So that is updated by using this flag. This is what each flag is what? One flip flop. Okay, so it is a 8-bit register, 8-bit flag register. So it is going to update the flags based on the ALU operation, arithmetic and logical operations. Okay, now come to the next section, that is instruction register and instruction decoder and machine cycle encoding. So here the instruction decoder indicates, so instruction register. So what actually instruction register? The data, the instruction which is stored in the memory, that can be fetched, okay, through some instruction, that will be stored in what? Instruction register. So after getting the opcode or instruction, so in the instruction register, that is also 8-bit register, so that is decoder, that is instruction decoder and machine cycle encoding. Okay, instruction decoder and machine cycle encoding. So it is going to decode, and machine cycle encoding indicates so what type of operation has to be carried out. So that is indicated to this timing and control unit. Okay, this timing and control unit is very, very important, because after getting the instruction from the instruction register, after that it is going to decode. Okay, instruction decoder and machine cycle encoding. So here we are having different types of machine cycles, that is memory read, memory write, IO read, IO write, opcode fetch. Okay, so many different memories, machine cycles are there. So after decoding, so it is going to give the indication to the what timing and control unit to perform the specified operation, whether you want to perform read operation or memory read operation, memory write operation, or IO read operation, or IO write operation, or opcode fetch, or any other operations, that can be done by using this timing and control unit. This timing and control unit is internally connected to all the blocks. Okay, it is going to give the indication. Okay, based on the instruction, it is going to give the indication to CPU what indication to it is going to give the indication to CPU what type of operation has to be carried out, whether you want to perform the ALU operation, whether you want to perform the reading operation from the memory, whether you want to perform the storing operation to memory. So everything is controlled by what it is going to give the indication, that is timing and control. The name itself you can see, timing and control unit, right? So this timing and control unit has some following signals. So let us see the one by one. So here DMA signal. DMA signals is what? Hold and HLA. So direct memory access. Okay. So if you want to access the direct memory, okay, in not without using the CPU, so direct memory access can be done by using this hold and HLDA pins, right? And here control signals are there. So what are the control signals? So here the control signals are that is IO/M bar. IO/M bar means what? Input output /M bar, that is memory. right? So either you want to perform the input output operation or what I mean memory operation. So that is what IO/M bar, that is decided by the IO/M bar pin, okay, which is available in 8085 microprocessor, right? And RD bar and WR bar is what, that is reading and writing operation, whether you are reading from memory or IO, or writing to memory or IO. So that can be done by using this RD bar and WR. These three signals are what, control signals, right? Now come to the status signal. These status signals are S0, S1. Okay, here S0, S1 is mainly used to identify the different types of machine cycles, whether there is opcode fetch, memory read, memory write, IO read, IO write. That can be decided by this status signals. So here the ALE signal is very, very important. So already I explained this ALE concept in previous architectures, that is 8085, 8086 architecture and 8051 architecture. The same operation here also. So ALE indicates address latch enable. So here the address latch enable indicates what, it is going to demultiplex. See here address and data bus is there. Address and data bus is what, AD0 to AD7. So here AD0 to AD7 is what, both address is there and data is there, right? Data bus is there. So it is a multiplexer at one. So this can be separated by using what, this ALE signal. If ALE is equal to 0, this AD0 to AD7 will act as what, data bus, that is D0 to D7. If ALE is equal to 1, so this AD0 to AD7 will act as what, I mean address bus, that is A0 to A7. So that is the main concept of this ALE signal, right? Now this ready signal, so ready signal is mainly used for what, whether the system is ready, okay, that is indicated by the ready signal, okay. Next, and also reset signals are there, reset in and reset out, okay. Reset in and reset out, it is going to reset the entire device, okay, whatever the device you're going to design. So there must be a reset signal, okay. So that is done by this reset in and reset out, right? Now and also here clock generation, for generating clock to the CPU. So here x1 and x2 are crystals, so we are going to give the crystals to, I mean inbuilt clock generator, and the clock out is what, it is going to provide the clock signal to the CPU to operate the corresponding machine cycle or corresponding the operation, because the clock is very, very important, okay. Now come to the power supply connection. So the operating voltage of this 8085 microprocessor is what, 5 plus 5 volt DC and ground, okay. This is what power supply connection, okay. Now let's move on to this one, okay, register side. So here we are having different types of registers, okay. There is WZ register, BC, DE and HL, stack pointer, program counter, incremental, decrement latch. Now let us see the one by one. So here WZ, so this WZ are temporary registers, okay. So this W and Z are having some speciality of this instruction, speciality of these registers. So here WZ will during what, I mean internal operation. For example, if you execute exchange instruction, what is exchange instruction actually? So the content of HL pair is exchanged with what, DE pair. So during that situation, the content of HL pair, okay, the HL pair is temporarily stored in WZ in order to swap the content from DE, okay. So in that situation, so this W and Z temporary register will be accessed, okay. This W and Z register is not accessed by the user, okay. So we are, for example, I am the designer, means I cannot use this W and Z registers, because it is reserved for what, CPU to perform the internal operations, okay. That's why it is called as what, temporary registers, okay. So here the temporary registers is only accessed by the CPU for some execution of some instructions, okay. So that is not applicable for the users to access that particular register. That is a speciality over there, right? The best example is what, exchange instruction. During exchange instruction, temporarily it is stored, okay. That HL content is temporarily stored in WZ and the content of D is transferred. After that the content of WZ, that is transferred to D resource. This is the concept, okay. Now come to the BCDEHL. So here BCDEHL all are 8-bit registers. So you can access the 8-bit operation. It can be used for 8-bit operations, okay, individually. Okay, either B register or C register or D register or E register or H register or L. These are all what, general purpose registers, okay. So here if you want to access some 16-bit operation, if you want to access the data from 16-bit data in the register, means, so here the pairing concept is there. The pairing concept the three pairing concepts are there in 8085 microprocessor. One is BC pair and DE pair and HL pair. Only these three possibilities. Either you can use BC pair or DE pair or HL pair. No other combination is possible because BE not possible to combine. DL not possible to combine. Okay, the only possibility is what? BC pair, DE pair and HL pair. Okay, if you want to perform what? 16-bit arithmetic operation. Okay, or if you want to use 8-bit arithmetic operation, 8-bit operation means you can use individually. Okay, whatever the registers, B or C or D or E or H or L. Okay, any register. Okay, so here BCD is that is the concept. But HL pair, so here HL pair is one specialty is there, HL for HL pair. Okay, so you can use general purpose also. Okay, and also this is mainly used for what? Indirect addressing mode. Okay, that is the HL pair is always act as what? Memory reference pointer. Okay, memory reference pointer during indirect addressing mode. Okay, so here in the indirect address, during indirect addressing mode, the memory address is available at what? HL pair. That's why this HL pair will act as what? Memory reference pointer. Already I told, no. So for accessing memory, okay, for accessing memory through only accumulator. Okay, so one more possibility is there, that is through HL pair. Some two instructions are there, like that is LHLD or SHLD. So LHLD indicates load the HL content. Okay, so that is direct 16-bit is loaded into HL content, that is load the data from memory. And SHLD store the HL data to memory, that is direct data available at HL content is loaded into memory. So memory can be accessed, okay, through this two instructions by using this HL pair. Okay, other than this, so only possibility is what? Through only accumulator. Okay, that is a specialty of this HL pair. Okay, so HL pair, sometimes in competitive examination they are going to ask which register pair is a memory, it will act as a memory reference pointer. The register pair is what? HL pair. Okay, so you have to remember this one. This is very, very important, right? Next, stack pointer. So here the stack pointer is what? It is a 16-bit register. It holds the address of, that is stack. Okay, stack, it is going to indicate where the stack pointer is available. Okay, where the data, location you have to store. So that pointer will be enabled by using this stack pointer. And program counter, already I have explained in the previous videos. The program counter, the same concept here also. So program counter is a 16-bit register. It holds the 16-bit address of next instruction to be executed. Okay, that is the concept behind in program counter. Okay, so next which type of instruction? For example, current instruction is executed means next instruction address is stored in program counter, and so on. Okay, that is a program counter. And here one more section is there, that is address buffer and address and data buffer. See here, address buffer already explained. The 8085 microprocessor consists of what? 8-bit data bus and 16-bit address bus. So here the 8-bit data bus is what? AD0 to AD7. See here, D0 to D7. Okay, so AD0 to AD7 is what? Multiplexer address and data bus, right? So that can be separated by using what I told? ALE signal. If ALE is equal to 0, these lines will act as what? Data bus. If ALE is equal to 1, these lines will act as what? Address bus. That is A0 to A7. And higher order address always available, that is A8 to A15. Okay, so totally A0 to A15 is what? 16-bit address bus. D0 to D7 is what? 8-bit data bus. Okay, so this is the basic basic operation of 8085 microprocessor architecture. Okay, so hope you understood all the blocks of this 8085 architecture. So hope you understood this concept, and hope you enjoyed this video. So please like, share and subscribe this video. Thank you.